a collection of complex things in factorization that third graders learn. All of them require some ideas, but as a summary of the contents of the textbook, please try to see if you can solve them all. 1 has square terms on both sides of the equation, so it seems that the square double square formula can be used. However, this formula cannot be used unless the entire term is in the form of a square. It is true that y is squared, but the term square of 6y, which includes 6, cannot be in the form of an integer squared. A squared integer like 4, 9, or 16 would have been fine, but 6 cannot be a squared integer. So we are wondering if we should use another formula. If it weren't for the y part of this question, we think we could have factored it like this using the addition and multiplication formulas. We often use formulas in terms of only numbers, but if we can add and multiply, we can use this formula. Even if it is not a number term, the formula can be used if it is a similar term. Don't be fooled by the square of y. Think of a pair of like terms using y that sums to 5y and multiplies to 6y squared. We want the number part to be 5 if we add, 6 if we multiply, so we can find a pair of 3 and 2. If it is a pair of 3y and 2y, we can make 5y when added and 6y squared when multiplied. In 2, it seems possible to use the squared part of 9x in the form of 3x squared. 16 can also be fixed to the square of 4. So, it seems that the squared doubled squared formula can be used, but this formula cannot be used unless there is a term that is doubled by multiplying the left term and the right term in the parenthesis. Please use the formula after confirming that it is doubled properly. For this question, multiply 3 by 4 and see if there is a term that doubles that number. (24x) is the term obtained by multiplying 3x by 4 and multiplying it by 2, so you can see that this formula can be used. (3) is almost the same question as 2. Convert 16 times y squared to 4y squared and use the formula. After all, it is necessary to check whether it is a term that is twice the product. For 25 times x squared can be converted to 5x squared, and 81 can be converted to 9 squared. You can use the square minus square formula. Five is 3 times x to the power of 2, so this part cannot be converted to the square of something using integers. Since it is possible to use formulas, we tend to think only about formulas, but there are cases where common factors can be obtained. In this question, all terms have multiples of 3. Take the 3 from every term out of the brackets and leave the remainder inside the brackets. The inside of the parenthesis is the form in which the formula can be used. If you get too familiar with formulas, it's easy to forget to consider common factors first. Be careful to think of common factors first, and then think of formulas. In 6, we consider the common factor in the same way, but since 2 always catches our eye, we tend to take 2 as the common factor. However, in this case, the expression in parentheses looks like it can use the formula, but it doesn't. In the formula, the squared term of x must be plus. So, correctly, we have to take a common factor of -2 so that the square of x becomes plus. By deliberately factoring by -2, the square of x becomes plus, but let's be careful about other terms. If we take the common factor -2 from -4x, we are left with plus 2x. Note that the signs are reversed. Seven has x plus y in common, so if you replace this part with other characters, it will be easier to understand if the formula can be used. I used an uppercase A, but you can substitute any letter. However, when replacing an expression with a single letter, uppercase letters are often used. When you're done using the formula, replace the parts you replaced. If you get used to it, you can use the formula without replacing it with a single letter. Because the x part is just x plus y. If you don't understand it without replacing it, of course you can solve it by replacing it. If you replace 8 with a single letter in the same way as 7, it will be easier to understand if you can use the formula. If you use the formula, it will return to the original 2x plus 5, but you can continue the calculation, so be careful. For this question we can also take a common factor. You can take a common factor of 2 in the opening parenthesis, and you can also take a common factor of 2 in the right parenthesis. I tried to color code red and blue, but these 2's are different 2's, so in the end, the two 2's are multiplied together to get 4. Of course, if you get used to it, you don't have to replace it with a single character. Even after you have finished using the formula, you may still need to continue the calculation, so be careful. 9 can also be used by replacing the common expression a-1 with a single letter. Ten does not have a common factor and is not in a form that can be used with a formula. It's a question we don't know where to start. In such a case, don't try to get the common factor all at once, just search for the part where you can get the common factor. If we only need these two terms, we can take the common factor x. Let's change the order of the terms to make it easier to read. Now we know that we can take y plus 1 as a common factor. For those who find it difficult to understand, it may be easier to understand that it is a common factor by thinking that y plus 1 is multiplied by 1. Take y plus 1 as a common factor and factorize. If it's hard to understand, replace y plus 1 with one letter and take the common factor. Similarly for 11, the same common factor cannot be obtained from all terms, so we will search for a common factor from some terms. In the first two terms we find a common factor of -2. We also find a common factor from the last two terms. Let's take the common factor at -2. When the common factor is minus, be careful about the sign inside the parentheses. In addition, let's take a common factor in a. Then we can see that x plus y can be taken as a common factor. If you factored by a without noticing the common factor of -2 at first, please think if you can make this x plus y from the first two terms. Then you will notice the common factor of -2.